And welcome back. Now on the bench today you can see there's a nice little TFT display from a Nokia 5110. Well, they say it's from a Nokia 5110. I'm not sure there's that many left in the world, but anyway, you can buy them pretty cheaply, and I'll show you where I got this one from. Now to drive this, it's very easy. There's just a few wires across the top. I mean, it's 8 in all, but don't get put off by that. There is a little bit of argy-bargy going on with this thing here though, because, and take very careful note of this, this is a 3.3 volt device. So you start connecting this up to 5 volts and the magic smoke will appear and the device will stop working. Now I have read on a couple of forums or articles that you can power this up with 3.3 but then actually connect the lines up to 5 volts. I don't think I'd be happy doing that at all. I've also seen a couple of circuits where the lines are connected via 10k resistors from a standard 5 volt. I wouldn't be happy doing that either, frankly, because you're still going to be effectively supplying 5 volts. Just because you put a 10k resistor in the way doesn't necessarily drop the voltage. It reduces the current, and of course if you take too much current the voltage will then drop, but it's still a poor way of doing it. Now if you did want to use resistors to connect up all the lines on here, I mean 3.3 volt supply is not a problem, is it? You can take that from your Uno or Nano or something, that you'll have the 3.3 on there. But the actual lines, if there's 5 lines you have to effectively voltage shift for the 5110. And there is an easy way to do it with resistors, and yes, it is perfectly safe. It's just a lot of resistors really, because you need 2 resistors for each line, so that's 10 resistors. What I'm using at the back here, and which I've shown you in previous videos, is in fact a voltage level shifter. And I'll show you how that works and how easy it is to connect up. And of course it does look like there's a lot of cables here, because well, there are a lot of cables here. I can't get away from that. But it didn't take very long to connect this up. I mean, I would say from absolute start to getting this all up and running took about, I don't know, 30 minutes just to get it up and running. And in fact, at least 5 minutes as that was wondering why it didn't work. See, I know. Benny was no help whatsoever this time. And I realised I got a couple of wires across down this end. But I mean, it was half an hour just to get this lot working, and it's easy to do, isn't it? So let me talk you through a voltage level shifter that doesn't require, well, a voltage level shifter proper, the poor man's way of doing it. It's a bit more fiddly though. As I say, you've got the 2 resistors, but let's have a look on screen how we might be doing that. So what you're looking at now is in fact something called TI-TINA, and it's a circuit development schematic system, and it's free to download from TI. The downside, if you can call it that, from taking it from TI is that you only get TI components. That's Texas Instruments. If you were to buy this from its normal supplier, it costs something like 50 quid for student hobbyist type version, and 79 or 80 quid for I don't know, a normal home user or professional or something. But I was just using this one just to show you really how it works. So let's have a quick look at this schematic that I've just knocked up here very quickly. So what we've got here, in fact, down the bottom is a 5 volt battery connected up to a 10k resistor on one side and a 20 on the other. So effectively this is taking 1/3 and this is taking 2/3 away, isn't it? Now I've got a couple of test points here, VF1 and VF2. I did stick this voltmeter in here, but it turned out I didn't need to do that. So what we're looking at here, look, is VF2. So that at this point here, basically at the junction of these 2 resistors, we can see it's 3.33 volts, which is exactly what we want, isn't it? So what that means is, you wouldn't be using a battery, of course. What you'd be applying here is the output from your Uno or Nano, so digital pin 7, for example, which we're using in this particular sketch, would come in at this end, go through a 10k resistor, have a tapping at this point to go to your Nokia 5110 TFT, and then a 20k to ground. Now, don't get too hung up about these values, because look, if we change some of these values, say this is it says here 20k, but say you didn't have a 20k, say you were going to put in whoops, I didn't mean to do that. Say you didn't have a 20, you wanted to put in, I don't know, 22, just as an example. I mean, it's close but not spot on, right? 22k, keyboard's the other side of my desk, that's why I'm twisting a bit here. So 22k, and it says it's now 3.44, which frankly I think would be tolerable by the TFT. Or what happens if you were going to put in an 18k, for example? Because I know that 18ks are readily available. It says 3.21, which would also be perfectly acceptable, I imagine. I haven't tried it, but I can't believe there'd be a problem. Obviously 20k is the perfect value, because that's what gives us the 3.3. So 20k, well, 3.33. So that's one way of doing it then, right? To split the output with this potential divider, because that's what that is really. So from the output from the Arduino, it goes via 10k and a 20k to ground. So it's ground here. If you look, it goes all the way around to ground. And of course the negative side of this battery, that's immaterial as far as we're concerned. And this side is where we connect up the output from the Uno, and the junction of the resistors where we connect up whichever digital line it is for the Nokia 5110 TFT. So that's an alternative method of changing the voltage levels from your Uno. If of course you're using something like a Sparkfun Pro Micro, that is a 3.3 volt device anyway, so you wouldn't have to do any of this. And you might think, given that this needs 5 of those lines, it might be better to use a different processor altogether. But anyway, I tend to use nanos, as you know, and this could be an approach that you're prepared to adopt. 10 resistors at the end of the day, it's not going to break the bank, is it? Okay, now you're probably wondering why this is flashing on and off, actually, because the only reason I'm doing that is to demo that we can actually turn off the backlight. And well, let's go back to the workbench. In fact, I'll talk about the actual voltage shifter at the back end just a little while. It's just going to be very difficult for me to actually sort of try and show you that. I have shown it to you in previous videos. I can't remember what it was on though, but if I remember or find out, I'll put it up on screen. If I start pulling this about, it will all just stop working. Now the other feature, if you like, of the library that we're using for the Nokia 5110, and there are several, is that we can adjust the contrast. Now this sort of screen actually works very well in bright lighting conditions. So in sunlight, for example, you'll be able to see this really, really well. It's only in dim or dimly lit situations that you'd need these backlights to come on. There's four individual LEDs here. Now they can take quite a bit of current, so I would not recommend leaving them on either, because if they, well, one, they're drawing a fair bit of current, and secondly, if they were to burn out, it would then sort of render the screen, well, unevenly illuminated for one. It'd just look a bit messy, wouldn't it? So I would say only light this up when you need it. Now of course I'm doing it programmatically. As this counts up, this little counter down here, I'm just proving we can write stuff to the screen. Every 200 counts, it will turn it off or on. It will toggle the light basically. But the contrast is a different matter altogether. I've put this into an analog port because the library allows us to adjust it just by reading a value on the analog port and sending out a particular value. So if I turn it left, you'll note it goes down to, well, nothing at this moment. And gradually turn it out, you can just about see it, and then it becomes darker and darker and darker until, you know, it just gets black. Now of course you wouldn't need a variable resistor to this. You could just get it to what you think is absolutely perfect, then read the resistor off, or use a tiny little preset resistor. That'd be nice. So you can set it once and then just leave it, because it shouldn't change, quite frankly. The other thing about this device is that although we're writing stuff on here, you know, text, right down in this corner here, you can see that there's sort of a smiley face of sorts, just to prove that we can address each individual pixel within the space allocated for a character. No problem at all. Now Adafruit have also got some libraries for this particular device, except take great care with that stuff from Adafruit, because their TFT for a 5110 is very different to this one. Well, I say very different, it looks very similar, but the pin out arrangement is very different. It's not the same as this one. So just make sure whichever one you get, you're using the right connections for it. I don't even know if the Adafruit library is actually going to work with this one. I haven't tested it. I imagine it would, because the standard chip that drives all this is from Philips, and it's a pretty standard chip, so I'm guessing it would probably work. But anyway, if you buy this one from the same place I bought it, or make sure you get the exact same board, then you can use the exact same library that I'm using and it'll all be absolutely fine. Now let's just take a step back from this before we delve into the code and so forth. Why am I even doing a video about this? Well, one, because everybody's got a Nokia 5110 TFT, haven't they? You haven't? Well, now's your chance to buy one, because A, they're really, really cheap. The downside is, of course, they are black and white. But you can draw pictures on them and shapes and whatnot. Adafruit library will do that for you. So it is powerful in that sense, but black and white means obviously it's not as pleasing to the eye, is it? Say the Benny in-out color touch TFT that I did a video on just a few weeks back. But then again, you could then afford to put one of these into lots more projects and just have sort of diagnostics or instructions on here, and better perhaps, or as good as, those 16:2 displays or 20:4 displays, which I've also used in many projects, and they work very well too. But I just thought it'd be useful to have a video on this ubiquitous device. Okay, so that's why I'm doing the video, because I think everybody should at least have one of these in their toolbox, because you never know when you might want to use it. Okay, let's just have a look at the code that runs all this, and then we'll talk about the level shifter and a couple of other little things too. And here's the code window. Now actually I'm using today the Sublime text editor just for a change. As you know, I normally tend to use the Eclipse IDE, or these days it's called, I don't know how to pronounce it really. I think it's called Slurber IDE, but basically it's the Eclipse one. But the Slurber one has got the Arduino add-on all built into it, together with a nag screen. But at least you can use it forever. This also has got a nag screen built in, by the way, but you can also use this forever as well. And I just tend to flip about a little bit just to see what advantages each one gives you. I'm going to be trying the Atmel Studio soon, but that's for another day. So here we are then in Sublime Text Editor with the Steno add-in for Arduino. So let's have a look at the code. Now remember, this is demo code. It just shows you a few of the capabilities. Some of the code is not mine. I've stolen it from I don't know where, probably Adafruit I should think, or elsewhere. But it's all the same. It's all pretty much the same. There's not a lot else you can do with the screen other than what I'm doing with it. So we're including this library, this PCD8544. I think this is basically the Philips chip that runs all these. Now I've got a pin here, pin 8, that's controlling that rather annoying flashing LCD LED, just to prove that we can. In fact, if I just disconnect the yellow wire, it will stop it flashing and stop irritating. There we are. So it's off now. Now, as you can see, if I just draw the camera back and zoom in on that, you'll see that it is in fact very readable, even in this light, which is not particularly well lit. It is, after all, now I've got the blinds down, I've got my video lights on and whatnot, but you can see it very well. And then the brighter the light, the better you can see it. In fact, let me go and get a rather bright torch and shine it on here just to prove the point. Right, here I am then with this torch. It's an LED torch, very bright. So I'm just going to turn this on. Now it's probably going to upset my video camera no end, but you should be able to see the screen, nothing else. So, oh, there it is. So you see, as not very good at doing this. Right, so there we are. Look, so that's very bright now. That's really lighting up the workspace here. But the screen is not being swamped, is it? I mean, it is being. I mean, you can see that just as well, no matter how bright. Yeah, you get it. Yeah, it's readable. So that's the point I'm making. Right, let's put it that way and reset everything. Okay, let's go back to the code window. Right, so that's the pin I'm using for the LCD LED, and basically you take that pin to ground to light it up. Now I have seen circuits where they've had a variable resistor in there to ground to sort of have an adjustable brightness, but I tried it, but then again I've only got a 10k resistor. You probably want something like a, I don't know, a 500 ohm resistor or something like that if it's going to work at all, but frankly I didn't see the need. So I think if I was using this in a real project, what I'd do is have like some kind of push button or touch button that lights this up for a certain length of time and then switches off again. Not too short, you know, perhaps 20 seconds, something like that, using exactly the same mechanism I've got here, but rather than it just doing it, you know, or a counter or something, actually do it when somebody presses the button. A bit like the old LED watches. I don't know if you remember those from, I don't know, 20, 30 years ago. You had to press a button on the front, didn't you, and then it'd light up for a little while and then go off again, mainly to save the battery, but also I think the segments actually burnt out after a while. Right, moving on then. This is a character. Now you're going to have to look at this sideways. So how can I put this? This is the bottom bit over here. Whoops. This is the bottom facing. So this bit where my cursor's wiggling about on here is in fact at the bottom of this screen down here, and the top is up here. So what you've got is a couple of eyes. There's the eye, and there's another eye, and there's like the nose and smiley mouth going down there like that. Okay, let's just move on from that bit. I've done a whole video on how to create these sort of characters from LCD. In fact, it was on the receiver end, the indoor version of the Cat Run weather station thingy, where I create some rather large, nice fonts so we can read the temperature from the other side of the room, and that gives you full examples of how to do this. Oh, there it is on screen. Look, that's the one. That's the video. Great. So anyway, we're using that library that we set up here, this PCD 8544. So we're creating an object now from that library, from the class that it's describing. So we're creating an object LCD, and what we're doing here is saying, right, begin, and we have to give it the size. Now, pretty much all the Nokia 5110s are the same size, as far as I can work out. 84 pixels wide by 48 pixels deep. Doesn't sound a lot, does it? But it's enough, as I said, to give either instructions or error messages, or I don't know what else. I'm sure you guys can think of loads of things what they could be used for. It is enough to get some information across. Then I clear it, because I did notice while I was playing about that sometimes, well, if you don't explicitly clear a position on that screen, it will just stay there. Yeah, you can overwrite it, but you know, you could crash into stuff that's already there. So anyway, LCD clear, just to clear it up. This is the LED control backlighting we just spoke about. So initially it's an output pin, of course, and I set it high because I don't want the current to sink to ground. Okay, so it's active low effectively. When that yellow cable that I just disconnected, when that goes to ground, that's when the current flows. So by setting it high, it stops it flowing. That smiley byte that was created up here, you put it into the memory by saying create char. I can't remember how many you get, not a lot, but you can create a few characters in here. Then we come on to the main loop. So we have our counter. I've got it as an unsigned long just so that it keeps going, really, because if you can imagine, look at it now, what are we up to? We're up to 227,000 already. When I first did this, I used an int, and of course it ran out after 32,000 because it was a signed int. So at 32,767 or thereabouts anyway, it overflowed and became a negative minus 32,766 and started counting backwards. So I thought, let's just make that long and it will count forever. You can have millions and billions in a long. So this is how you set the LCD. You set the cursor, column then row. So column is in pixels going from left to right. Row is, well, row of text going down. So 0, 0 means, okay, top left. When you say print something like I've got here, it will work out where it needs to print from. So what I'm going to do actually is just turn on the light permanently, just so we can talk through a few things on here. Back in just a jiffy. Right, okay, the light's permanently on now just by connecting that cable from the TFT to ground. So what we're saying is, even though we've put the cursor now on the screen at top left, when we print stuff, obviously it can't start printing from here, it's got to come down a bit, hasn't it? So the print statement automatically works out where it's got to go to print that. So it's sort of a helper class really, and it really makes printing to the screen very much easier. So you can just do this row after row. So we're printing stuff here, look, on first pixel on the left, so extreme left, second row though, so it doesn't mean second pixel down, second row down, third row down. But now when we write the smiley, because I've put it right over in this corner here, I've had to work out how many pixels across. So it's 78 pixels across, but the fifth row down. Okay, I mean, if you try this sketch, it'll be blindingly obvious how it all works. Now, within the loop, I've got another loop. So in fact, this loop, the main loop, never ends actually, because it's stuck in this inner loop. And what I'm doing is reading the analog level of this pot. Okay, this one here. I'm then mapping it between 0 and 127, which is what the library expects for this, because this LCD sets the contrast level between 0 and 127. So it does that. Then it writes out the cursor on that bottom line, which you can see it's still counting away quite merrily. Then it increments the counter and says every 200. So as the counter's counting up, it divides by 200. This bit is modulus, which means in layman's terms remainder. So counter divided by 200, what's the remainder? Well, if it's 0, that means 200 has been exactly counted. Then turn the LCD either on or off, whatever it wasn't before. Again, I've made a little explanatory note here just in case you don't understand this. I guess it does look a bit weird now I think about it. It's just something you learn to use. So what it's saying is, go and read the LCD state. That means what state is it currently? Is it high, that, as it is now for example, so it's lit, or is it low, which means, no, actually that's the wrong way around, isn't it? Remember, it's active low. So is it high, which means off, or is it low, which means it's currently lit? All right, so let's assume that it's currently lit. So the value it's coming back out of this highlighted statement will say low. And we're saying that exclamation mark says not low, so therefore high. Go and write now to the same pin high, and that's how you toggle the value. Okay, and well, guess what? That's the end of the sketch, because it's so simple, isn't it? Now I've not included any sort of graphics or things like that, but you can include all those, and there's plenty of libraries out there. But I'm just getting you sort of as an introduction to this TFT. And well, as an introduction, I think this works quite well. Most people probably will use it for text, but there's no reason why you can't use graphics on there as well, just to enhance the value. So the next question is where did I get this from, and just how much was it? I mean, for $10 it's not bad value, but of course it didn't cost anything like $10. You've got to be kidding me, I'm not spending $10 on something like this. So let's have a look. Where am I? I'm on the browser now. There we are. So £1.40, which equates to $1.77, and I know that because I just looked. So $1.77, £1.40 gets you this screen, and I think that's pretty good value. However, you do need, as I say, this shift converter, this level converter, if you're not going to use those resistors as I previously showed you. And how much is that going to cost? Well, let's flip over to that. This is all from AliExpress, by the way. Who's this from? Well, this one's from Module Fans, as you can see there. But the next one, let's have a look. So this is the level shifter. Now, there's a couple of things to be aware of here. Now, they're not £3.63 each. Don't start getting wrong. This is for 5 bits. All right. So 73p each. And I'd almost say, well, it's probably worth getting 5. I mean, why would you order one, use it, and then have to wait another 4 weeks to order another one in 6 months' time? But entirely up to you, of course. But that's pretty cheap, isn't it? Now, what I would say is, at this point, do not buy a 4-channel level shifter. Why? Well, because if I was using a 4-channel shift on here, I'd have to use 2, wouldn't I? Because I've got 5 wires that need shifting. And that's occurred to me more than once, where I've had to shift more than 4 wires. So I would say ignore the 4 channel level shifters, even though they're pretty cheap, but not particularly much cheaper than these. And of course they must be bi-directional. Okay, it says bi-directional here, so the information can flow back from whatever it is you've connected it to, say here. So this might send information back. It doesn't, as it happens, but say this was a touch screen, for example, that would want to send some information back, wouldn't it? So it'd have to flow through that level shifter and then into your Arduino. So you do need it bi-directional, and it's simplicity itself to connect up. One side is the high side, the high voltages, and you connect 5 volts to that. So on this, let's just zoom in on one of these pictures. Will it let me? Yes. So on one of these, for example, you can just about make it out there. There they've marked it as A, 1, 2, 3, 4 and all that. So that would be the high side, up to 8 channels, and you connect 5 volts on a different pin to that side. And on the other side you have the 8 channels, and you connect your 3.3 volts also from the Arduino, and all the levels on that side then come out as 3.3. It's a clever bit of engineering, and of course will save your actual product, because although the website did say, if we just go back to the website, I think it says down here, yes you can use 5, but no you can't actually. So what it says here, okay, it does mention here about the screen perhaps working loose, didn't with me. Use a 3.3 volt controller, it says here, otherwise the display could be quite vague. Vague as in burnt out perhaps, I don't know. 2.7 volts to 3.3, 5 volts is okay, but part of the screen becomes black when tested. Well, that sounds a bit of a warning to me, so do not use 5 volts. Now it also says the data interface level is 2.7 to 5. Well, it's not. I mean, the spec for this device is 3.3 volts. The fact that it might tolerate 5 volts for a bit or forever is just pure blind luck. And the thing is, you might connect it up at 5 volts and it works, and you think, well, what's the problem? You build it into a project and 2 months down the line it just goes poof, that's it, doesn't work no more. So it's just not worth risking. At the very least you need those 2 resistors that I showed you, okay, but better still are these level shifters. I mean, to be quite honest, although I've got lots of wires on this board now, that's because of course I've got loads of wires going into it and then loads of wires coming out again. So there's effectively 5 wires going in, 5 wires out, plus the power line, and of course this LED line. So that's why it just happens to look a lot. If you were to actually mount this on a board, a strip board or a what do you call it, development shield or something, then you just wouldn't have anywhere near as many cables as this. But this is the problem with demoing stuff, you do tend to end up with a bit of a rat's nest. And in fact, on the other side of this, I'm going to take this off the table now, stuck on with blue tack. You notice that I didn't use the pins that they sent me. They sent me like a strip of 8 like this, but they were vertical, and I thought, well, if I solder those in vertically, yes, I could do the demo easier because it means I could just plug them directly into a breadboard. But when it comes to actually connecting it up in a project, it makes this rather fat. So I've used right angled connector pins, as you can see, and look how lovely and flat it keeps the entire thing. So I'll be connecting it up exactly as I've got it like this, with 8 pins, ribbon cable, or DuPont cables in fact, to whichever circuit board I need. The other thing I tend to do, because these are all individual now and they could easily come off, is just get some hot glue. This is in the final project, hot glue. These will all be turned around the other way so they're black, so the actual connector is not exposed, so that you get like this one here, and just run some hot glue across the back of it, just a little strip, and then you'll find that the individual pins won't pull out, and that's all you need. So yeah, so that's just something I thought I ought to tell you. Right, let's just go back to the description of this device as per the seller. So it's talking about the interface level being that. I don't believe that time for a second. Also the backlight Well, it says backlight power supply voltage highest 3.3. Well, we're not actually supplying power backlight voltage. We're supplying 3.3 to this, but the backlight is just being, well, grounded effectively. That's what that yellow wire was doing. So I don't really know what that means. Here's some of the connections that it's talking about. I'll draw those out and show you those. And okay, just goes on a bit about this, that, and the other. It does say, look, it can take 200 microamps, can it? So it could be good for battery power. I haven't really investigated the LCD library that I'm using too much. I just want to get the thing running. But if it was that low, obviously not with the LEDs running, it's not going to get 200 microamps of those running, but without them, it could well be very low. Because as I say, it's only 1 bit per pixel, unlike a color screen, it'll have 3, if not 4 bits per pixel. So yeah, it could be very low current and useful for battery powered or solar powered projects. Okay, let me show you then very briefly how we connect all these wires to the level shifter and from the level shifter out. I'll just do 1 or 2 as a sort of a demo, but I think you'll get the idea then. Right, back to the workbench, and I'm going to put my little work pad on here and just draw it out. So in general terms, this is how level shifting works, right? You have your microcontroller and a GPIO pin, just any one, okay, but it's at 5 volts of course. Now you have to send this into a level shifter on the high side. Alright, so that is a 5 volt high side. Now you also connect up the 3.3 volts to the level shifter, and the opposite output of that input will be magically transformed to 3.3 volts. It's well, very easy to use really. I mean, there's nothing more to do about it. Great. Now, an alternative method of doing it, and this is using 2 resistors, as I showed you in the TINA circuit diagram. So you have your output, it goes through a 10k to begin with, and then a 20k to ground, and that will give you at the junction there exactly 3.3 volts, which is just, well, maths and physics really. That's how it works. There we are, 3.3. That's it. Beautiful. So those are the 2 ways in which you can level shift your voltages. Now, one thing I did forget to tell you, of course, why did I in fact put this loop within a loop? Well, the reason for that is I wanted to write out to the screen as fast as I possibly could without doing all this gubbins at the top here. Again, I didn't want to write out all this, you know, high Arduinoites and all this again and again, because that would slow it down. So the only thing I'm doing is reading the analog version of the pot here to get the contrast, so that still works. Print out the counter down the bottom, and then every 200 counts switch it on or off. So if we zoom in on that counter there, you can see that's quite happily counting up, and it's quick, isn't it? It's quick and it's clear, it's not blurred in any way. I mean, you can always adjust the contrast until you think, well, that's it, stop now. So that's too much, obviously. There we are. I mean, that's pretty good, and it does look nice and clear. So yeah, I think that's Benny. Stop it, stop it. I think he wants to join in. No, off. He does want to get involved. Wants to play with that, I think. Right. So yeah, I think that probably covers it really, to be quite honest. I'll put the whoops, going the wrong way. I'll put the library and other details that I've found below this video, all right, as part of the thing, and of course the sketch, which is easy enough to do as well. And well, that's it really. Then just go and order it from AliExpress or wherever you think. But it is pretty cheap, isn't it? And it's worth doing, because as I say, having this in a project just makes it a bit more, I don't know, professional, I suppose, isn't it really? Right, I better go before Benny goes and destroys everything. So right, okay, thanks for watching, and I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.